So in the previous lesson, we learned about what a loop was. And in particular, we talked about different types of loops in terms of how we would use them. The first one we discussed was something called a counted loop. And a counted loop is simply a loop that iterates a specific number of times. So it might loop exactly 4 times or exactly 5 times. Or it might loop from a starting value to an ending value, depending on what your goal is. But it always loops a specific known number of times. And the analogy we gave was that idea, your morning routine, and you get up and you do the exact same thing all day long, every single day, 5 times a week. So the loop here, it repeats itself 5 times. Okay, so that's a counted loop. And the second analogy we gave during that lesson was all about making coffee. And when you go to make your coffee, you get your coffee, you pour your cream in, you put your sugar in, you stir it 3 times, you tap the side of the cup to make sure the stir stick doesn't drip, and you enjoy your coffee. Later on in the day, you need another one, so you repeat that whole process again. Later on in the day, maybe you need another one, and you repeat that process again. When does it stop? Well, it stops when you start to get the shakes and you realize that you're over-caffeinated. So in this case, it doesn't stop after a specific number of times. There's some days where you require more coffee than other days. Don't drink coffee, you're too young. But in any case, the whole idea here is you stop based on a different condition other than counting. In this case, we're stopping when we're ready to stop. We've had enough coffee. So that idea is called a conditional loop, and that's the focus of today's lesson. What we're looking at is, well, when do we stop? What is the condition to tell us to don't loop anymore? So a conditional loop repeats a block of code indefinitely, forever, until some condition is no longer met. What condition? Well, that depends on what you're trying to do. If I'm making a password program, that condition might be something like, well, let them go forever until they get the right password. Okay. If I'm making a game loop, it might be go forever until the user hits escape to quit. So we have different situations that result in a different necessary loop. So let's take a look at what the syntax for a conditional loop looks like. I got great news for you. It's almost 100% identical to a simple if statement. So much so that I'm going to demonstrate a while loop by using an if statement. So let's go take a look at a piece of code for a second. So here we see a fairly straightforward program. What does it do? Well, we clear the screen just to make things look pretty, but then we created a number and we asked the user for a positive number. If they entered a number that was less than or equal to 0, well then I said, well, that number's too low. Try again, please. And we asked them for another positive number. Well, then it continues on with the program. It doesn't account for the fact, like, what if the user enters another negative number? It's perfectly reasonable for them to do that. They shouldn't do that. They were told not to do that, but they may do that. So what does this program do in essence? It says, give me a positive number. No, I'll give you one more try. And then whether you get it right or not, we're moving on. That seems a fairly reasonable thing to do, I guess. This is a simple if statement. It makes a choice, and it gives the user one more shot. I'm going to change one thing in this program, and by doing so, it's going to change the entire flow of the program. I'm going to change this word if to while, and that's it. We're done now. The difference here is twofold. First of all, syntax-wise, was only that one word. We changed if to while. Now just think about that logically in terms of the English semantics of this. If this statement is true, do this logic. Continue on. Versus while this statement is true. While implies a time associated with this thing. So while this statement is continually true, go in and ask them again for another positive number. Comes back up. Are you still not positive? All right, ask again. So the difference here is this one will ask that person forever until they actually enter in a positive number, until they enter a number that's greater than 0. There's the difference here. So let's go back and show the logical change. So here's the if statement. It's going to ask me for a number. Please enter a number. I'm going to say 3. And immediately it's done. Thanks for your number. Okay, let's try it again. Let's do -3 this time. -3. Your number was too low. Try again. -3 again. Thanks for your number. -3. Not too useful. Let's try again. Let's change this to while. And run the program again. And again, we'll start with giving it a 3. Immediately it says, yeah, we're good to go. It didn't even enter the while loop because 3 is not less than or equal to 0. Just skipped that part and went on with the rest of the program. Now let's try it with a -3. Oops. -3. Your number is too low. Try again. How about -4? Your number was too low. Try again. How about -17? Your number was too low. Try again. This will go on literally forever, as long as I keep entering in negative numbers. But as soon as I enter a positive number, it finishes. Because then when it went back up to test that test condition again, that test condition no longer succeeded. So it skipped the rest of the loop and went on with the rest of the program. So that's the difference between if and while, but it's also that shows you the difference between a counted loop and a conditional loop. Counted loop will only do it a specific number of times, whereas a conditional loop will do it forever if it needs to. All right, now yesterday when we first introduced loops, we talked about the fact that every loop is made up of 3 parts. It's made up of a comparison variable, it's made up of a comparison statement, and it's made up of a change statement. So the comparison variable is the variable that's being checked upon to see whether we should continue to loop. The comparison statement is the actual check. Is this variable, we compare that variable against some type of target value. Now in a counted loop, that was a target n value, like a number. In a conditional loop, that could be something else. For example, it might be just a Boolean value. Is this value equal to true? Yeah? All right. Moving on. And then finally, the change step. And this was the most important aspect. The change step says, change the comparison variable so it takes a step towards the end value. So it needs to change so it progresses towards that end. So eventually that loop will finish. So in a counter loop, that makes sense. We always, we're either adding 1, subtracting 1, or somehow changing that counter variable towards that end value. But with a conditional loop, it's not really the same. First of all, we do have all 3 parts. Let's take a look. We need a comparison variable. What's our comparison variable? Well, it's number. That's the value that's being compared. Where's it being compared? In the comparison statement. So there's the second part. And then we have our logic inside. And the final piece that's needed is the change statement. Well, I'm not adding 1 to number or anything like that. Where is number being changed? It's being changed right here when we ask them for it. We don't know whether the user is going to enter a number that's closer to a positive number or not, but we do know it's changing. And that change implies that there's a chance that it may actually be valid this time around. So even a while loop still has all 3 parts: the comparison variable, the comparison statement, and the change statement. So all loops are basically the same thing. It's just how we use them and what makes sense and when to use those things. So this is what we're looking at in terms of a conditional loop. There's nothing else to it. Just change your if statement to a while statement and you're done the syntax. Easy peasy. Okay. But there's other scenarios where we need to deal with some different types of problems. There may arise a point in your code where you've realized that, why am I still looping? For example, maybe you created a program that analyzes a piece of text. Maybe it's looking for the first A in a piece of text. So you're looping through it character by character, and you find the A. Well, since you found it, that means you don't need to check the rest of the characters. So you should stop. So how do we make it stop? Well, there's a few ways. First of all, you could have a while loop that says that maybe checks a Boolean value, and you set that Boolean value to true when you actually find the character. And that's perfectly valid. But there may be other times where that doesn't make any sense. So there is a way that we can actually exit out of our loops early. And to do that, we use a break statement. Everybody remembers a break statement. We talked about break statements when we first learned switches. And what a break does is it exits out of the current control structure you're in. Now back then, that was the switch statement itself. It said stop doing any more code in this switch. But if we put a break statement inside of a loop, it will actually stop it will actually stop executing the loop. It will jump out of the loop and continue on with the rest of the program. We could actually modify this code here to use a break statement, for example, when they actually enter a positive number. So I could have an if statement right here that says, if number is greater than 0, break. What that does is, this is actually not a good thing to do in the way that I just wrote that, but I'm just demonstrating the fact that we could use a break statement here. What this does is, as soon as the user enters their number, we're immediately testing to see whether we're done looping. Rather than waiting for it to go back up to the top and letting it exit naturally, we're forcing it. And like I said, that's not necessarily a good thing, and I'll explain why in a second. But this will, if that number is positive, it's going to get into this, see that break, and immediately jump out and continue on with the rest of the program. It will do nothing below this point. So there are a few key points here. First of all, your break statements absolutely must be inside of an if statement. If they're not, if I just had a break statement just sitting there, then this is not a loop at all, because as soon as it sees the break, it's going to exit the loop. So it must be inside of an if statement. Now, I told you it's probably better to end your loop naturally versus forcing it with the break. And here's the analogy for that. There are many ways to shut down a computer. You can go in, hit the Windows key, say shut down, and when you do that, it saves all your data, it saves all your settings and everything like that, and closes down gracefully. No problem. There's another way. You could just walk over to the wall and pull the power plug out of the wall. And that will do the exact same thing. At the end of the day, it's still off. One's a little bit more harsh, and it's probably not going to be too good for your computer. But it does technically do the same thing. Well, that's what using a break statement is like. It's like walking over and pulling the plug out of the wall. Yeah, it works. Not the best thing, though. When in reality, what you should be doing is trying to let the loop end naturally, which means creating your while condition, creating your test condition in a way that when it gets back up, it doesn't need to enter the code again. You don't have to force it out. But again, there are scenarios where it makes sense to do that. So I'm going to show you another example, a very simple example that you've seen before in past tasks. So this is our very old school password program. You might remember this from when we first learned simple selection. Here I've put it in a while loop though. So I've created a variable called numTries and I set it to 3. And I've got a password and a variable for the user password. And I can say while numTries is greater than, or not numTries, numTries, while numTries is still positive, which means we still have tries left to guess our password, we're going to go in and we're going to ask the user for their password. And then we're going to test it. We're going to see if they got it right. If they got it right, if it equals the password, then we're going to say access granted. Otherwise, we're going to tell them access denied. Now we just used up a guess, so we subtract 1 from numTries and we go back up to the top of the loop and see if they still have tries available. Let's show this. I run my program. It's going to come in. It's going to ask me for a password eventually. Here we go. Enter a password. I don't know. Bob. Access denied. Enter your password again. Okay. Password. No? How about 1, 2, 3, 4, 5? Oh, access denied. Now the program's done. So it gave me 3 tries. That's great. But what if we run into this scenario? The password over here is actually secret. So let's say I get the first one wrong. But now I write in the actual correct one. Access granted. Oh, it's still asking me for another password. Well, that's no good. So here's the problem. We've created a loop that says as long as we have tries available, keep asking them. Even if we got it, this loop continues because we didn't tell it to exit. Now, here's the simple solution. The easy solution is to pull the plug. When we get the answer, when it actually does match, we just break out. There's no need to continue to ask them. Let's try again. So we're going to get it wrong on the first one. Access denied. Second one, we're going to get it. Secret. Access granted. And the program ends. It actually jumped out of the loop. Now, is this the proper way to do this? It is a way. It doesn't necessarily mean it's the proper way. So you could have just as easily put a separate check inside of your numTries. So you could have said something like this. If num tries is greater than 0, and we haven't guessed the correct password yet. So and user pass dot equals password. So what we did here is we created a compound statement that says as long as we still have tries left and we have not yet got the correct password, then ask them for another password. In that case, we can actually get rid of that break statement and things will actually end elegantly. So we'll try the exact same thing we did last time, get it wrong the first time. Now we're going to get it right. And we get the exact same results. This time the loop ended naturally, gracefully. We didn't force it. We created a condition, a test condition that would allow it to end effectively. Now, the reason why I showed you this is because pretty much whenever you're using a break statement, there's almost always a way to rewrite your tests and conditions in a way that you don't need to use that break statement. But I'm not going to guarantee that because there are always scenarios that come up and you can't think of every possible situation. So do your best to keep your code clean and elegant, but realize that sometimes you need to force it. Okay? So the last thing I wanted to talk to you about was how do we document loops? Where do we put a comment? Well, I told you when we talked about selection statements that all of our control structures from here on out will be documented in the exact same way. And here it is. You put one comment above the entire loop structure that describes what is the goal of that loop. What is happening? What is the purpose? In this case, we're saying give the user 3 tries to enter the correct password. That's it. Now inside of here, you would document your code inside of here normally. So I would have one comment here, which says something like, let's say retrieve the user's password. Inside of here, we are comparing the user's password against the real password, the stored password. And reduce the number of tries available. Reduce the number of tries available. That's it. That's a fully documented loop. We have one comment that describes the purpose of the loop itself, and then we have a comment for each one of our blocks inside. Remember, we don't document else statements. We only document the overall if itself, which discusses the whole thing. And that's it. Don't do any more than that because you don't need to. What happens if you have a loop inside of a loop, though? What if I had a for loop inside of here? Right? Oh, I'm just going to make this up. I is less than 10, I plus plus. Who knows what this loop is doing? It doesn't really make a difference. So this loop itself would also get its own comment. So every loop gets its own comment, just like every if gets its own comment. Okay? So that's how we document our loops. And we're going to stop there. The next lesson is going to go into more detail about having loops inside of loops. And if you guys remember that term, nesting. All right. Good luck on your homework.